Hey guys, so today is day number 5 of volume. So again, we've been talking about volume of a sphere, of a cone, of a pyramid, of a prism. So today we're finally going to take that and actually apply it to kind of some real world situations, a couple of word problems here that we have today. So by this point, we've pretty much covered all of these here, we talked about cylinder, cone, pyramid, rectangular prism, or a cube, and then of course a sphere. We're not actually going to get a chance to talk about a triangular prism. All right, so we're going to be focusing on these 5 over here on the right today. Example number 1, let's just go ahead and jump into it. It says a company makes wax candles in the shape of a cylinder, right? So here's our cylinder, okay? Shape of a cylinder. Each candle has a radius of 5 inches. So let me actually go ahead and label that, right? So from the center to the side here, the radius is going to be 5 inches and a height of 10 inches. So from top to bottom, this measures a total of 10 inches. If the company used 5,000 cubic inches of wax, how many candles did they make? Well, again, this is the material that you have to make the candle. So let's just talk about, well, how much does one candle, right, one of these products, how much wax does it take up? Well, let's go ahead and find the volume of a single candle, right? So make sure you have the right formula. Volume of a cylinder is pi r squared times r height, right? You take the area of the base and you just multiply that by your height. You start stacking a bunch of circles and eventually create a cylinder when you 3D print a bunch of circles on top of each other. So let's go through and calculate volume of just the one single candle. So volume is equal to pi, and then r, my radius here is 5 from the center to the side, right? From the center of this candle to the side, that measures 5. So it's going to be 5 to the second power times, well, my height, h. H here measures 10. All right, we're going to go through and just multiply a couple of things. I'll try to show as much work as possible. Pi, what's 5 to the second power? Remember, that's 5 times 5, not 5 times 2. So 5 times 5 is 25. So I have pi times 25 now times 10. Well, let me multiply 25 times 10. Volume is equal to pi times 25 times 10 is 250. Now the last thing we're going to do here is multiply by pi. We're going to multiply 250 times 3.14. So let me go ahead and do that. 250 on my calculator times 3.14. That gave me a total of 785. And again, this is cubic inches. So here's the deal. This is how much wax one single candle is taking up. It takes 785 cubic inches, right? And that should be an N right there, not an M. All right, so if I'm worried about how many candles can they make, well, we're going to take that total wax, right? We're going to take the total and we're going to divide it by the individual candle, right? Let's see if I can actually write that down. By the individual candle. So our total wax that we have was 5,000 cubic inches, so 5,000. And we're going to divide that by the 785. That's how much it takes to make up one candle. So what is 5,000 on my calculator? 5,000, not 500, divided by 785. That gave me a total of 6.369, and it goes on for a while, 4267. So here's the thing. How many candles can we make? Please don't say 6.369. No, you cannot make 0.369 of a candle, right? You can't make a partial candle. That's not going to sell. You're going to fill up the candle like, right, not even all the way up, right? Just a smidge of the way up. No, so how many candles can we make if we have 5,000 cubic inches of wax? We can only make 6, right? We actually have to round down. So how many candles did they made? They made
now
6 candles. All right, so again, that is our final answer. So be careful with these types of questions, guys. Right? Can you make a 0.36 of a candle? Oops. All right, sorry about that, guys. I had to make sure Alexa stopped trying to pair up with everything. Amazon's taking over. So again, you can't make 0.36 of a candle, right? So again, you're gonna have to round down. So be careful again. Be careful. Be careful. All right, example number 2. So it says, which hydro flask will end up costing the most? Justify your answer. We're going to be using 3.14 for pi as usual. So here we have 2 different hydro flasks, right? HF hydro flask number 1 has a radius of 4 inches and a height of 12 inches, but this one's going to cost us 2 cents per cubic inch, right? It's going to cost us 2 cents per cubic inch. So let's go ahead and find the volume and then figure out the actual cost of that hydro flask. So hydro flask number 1. So I'll put HF number 1, hydro flask number 1. Since we have a hydro flask, right, it has a radius and a height, right? This is pretty much a cylinder, right? So we're working here with the cylinder. So let me make sure I write the formula for volume of a cylinder. So volume is equal to pi r squared times h. So if we fill in our, well, pi is going to stay the same, but our radius, well, our radius is up above. It says 4 inches. So we're going to plug in 4 to the second power, and we're going to multiply that by our height. Our height up there is actually 12. If we go through and work that out, we should end up with a volume for hydro flask number 1. Let me actually go through and multiply that out on my calculator. So I'll verbally explain what I'm doing. First, I'm doing 4 to the second power. So 4 times 4, not 4 times 2, which gives me 16. And then I multiply that by the height, which is 12, and I get 192. And then the last thing I'm going to multiply here is times 3.14, times pi, times 3.14. That gave me a total volume of 602.88. And of course, this is cubic inches. So that's the volume of the first hydro flask, but I want to know what is going to be the cost, right? Well, it's right here. It costs us 2 cents per cubic inch. So what we're actually going to do is we're going to multiply that volume times 0.02, 2 cents. We're going to multiply that by the cost of cubic inch. So you're really just multiplying by 0.02. So I'm going to go ahead and do that right now, times 0.02, and I get a cost of $12, and I'm going to round this. It says 12.057. I'm actually going to go ahead and round that to 12.06. So $12.06. That is the cost of the first hydro flask. Okay. Let's go ahead and take a look at the second hydro flask. Let me pick a different color here. Hydro flask number 2. Well, this one has a radius of 6 inches, a height of 8, but this one cost $3 per cubic inch, right? So just because it costs a cent more, is it really going to cost more? Is it going to be less? Well, let's figure out the volume, and let's just multiply it by that cost per cubic inch. So one more time, since we do have a cylinder, volume is equal to pi r squared times height. Make sure that you guys have the correct formula for volume, right? In this case, it's cylinder. And I'm going to plug in everything that I know. Volume is equal to pi. What is my radius? My radius up above said 6 inches. So 6 to the second power times what's my height? Up above it says 8. And I'm going to go through and do all that work on the calculator. I'm verbally just going to explain what I'm doing. I don't have enough space to show all of this work. So give me 1 second, and if I can figure out my calculator, there it goes. So what I'm doing first is 6 to the second power, so 6 times 6, which is 36. I multiply that by my height, which is 8. I got 288, and then I multiply that by pi times 3.14, and I get a volume of 904.32 cubic inches. But again, that's just the volume of the hydro flask. We have to multiply it by the cost, right? It costs 3 cents per cubic inch. So I'm going to multiply times 0.03. So times 0.03. I get a total cost for the second hydro flask. And again, I'm going to round here to the nearest hundredth. All right, think of money. I get 27.129. So I'll actually round to $27.30. 13 cents. So which Hydro Flask will end up costing the most? It's actually going to be number 2. All right, number 2, we can say Hydro Flask number 2 costs the most, right? Whoops, costs the most. That is our final answer. And of course, down below is our word to justify that answer. Right, if you actually wanted to figure out, well, how much more does it cost? Well, what's 27, right, dollars and 13 cents minus $12.06? The second Hydro Flask cost $15.07 more than that first one. All right, let's move on to number 3. All right, number 3 says the volume of a rectangular pyramid is 360 cubic inches. If the length is 9 inches and the width is 4 inches, what is the height of that pyramid? So they don't give us a picture. So what I'm going to do is my best here to draw a rectangular pyramid. So rectangular base. Let me draw that base of that pyramid, right, as best as I can. A triangle, or not a triangle, a rectangle, as best as I can. There we go. And let me go ahead and finish the rest of this to the best of my abilities, just to give you guys a picture of what's happening here. All right, so there is my pyramid, not the prettiest thing in the world, but let's go through and label a couple of things, right? It's just nice to have a visual. So they tell us that the volume of the pyramid is 360 cubic inches. So that's our volume. We know our volume. We know our volume. What else they tell us? The length is 9 inches, and the width is 4 inches. So let me go ahead and just label that on my picture here. So 9 inches, I'm going to go ahead and choose the longer one, 9 inches. And my width over here is 4 inches. They're asking us to figure out what is the height of this pyramid from the very tippity top of that pyramid down to the center, I'm trying to figure out what that is, that H. So we're going to have to go ahead and use our formula, plug in everything that we know, and hopefully we can work our way backwards to find the actual height. So volume of a pyramid. Hopefully I remember this one. It is length times width times height, all of that divided by 3. And again, if you guys forget, feel free to go back. And I actually did get it correct off the top of my head. It's been a while since I've done volume. So it's just always nice to go back and double check, hey, I actually have the right formula, right? So there we have it. Let's go ahead and plug in everything that we know. Well, V represents volume. I actually know my volume. My volume is up here, 360 cubic inches. So I'm going to write 360 is equal to, start filling in my length. Well, my length is 9, right? We actually see it up above here. It says length is 9 inches. We actually see it in the picture. So we're going to say 9 times, what's my width? What's W? Well, width is over here. It's 4. 9 times 4 times H. Well, I don't know my H. That's what we're trying to find. We're trying to find our height here. So we're going to leave that as H, and this is all divided by 3. Well, you just have to work out a multi-step equation. It's an algebra 1 problem. What I would recommend that everybody do at this point is get rid of that fraction. That's what I would recommend to do first. How do we get rid of dividing by 3? The inverse, what's the opposite of dividing? It's to multiply. So we're going to multiply both sides by 3. Whatever I do to the right, I do to the left here. So what is 360 times 3? 360 times 3, that gives me 1,080 is equal to 9 times 4 times H, and these 3's end up canceling each other out. All right, if I continue to work this out, I would recommend multiplying your length and your width here. 9 times 4, which is 30. Let me write this out. 1,080 is equal to 9 times 4, which is 36. And of course, bring down your H, 36 times H. Well, you have just one more thing that you have to do. That last thing here is simply to divide both sides by 36. So what is 1,080 divided by 36? I end up with 30. 30 is equal to H. So what is the height of this pyramid? Let's go ahead and just write one final little sentence here. We can say the height of the pyramid is 30. 30 what though? 30 what? 30 and it's just inches, right? It's not cubic inches. We're not talking about volume. We're talking about a height. This height right here from the very top to the bottom is 30 inches. This is a pretty tiny pyramid, right? Not actual live scale Egyptian pyramid. All right. Example number 4. So it says you want to make the pool in your backyard bigger. Okay, so we already have a pool, right? So we have this pool in our backyard. We're trying to make it, I'm assuming, just bigger. Invite more friends over. It is currently a rectangular shape. Okay, so we have a rectangular shape with a length of 10 meters, a width of 5 meters, and a depth of 5 meters. So let's see if I can draw this as best as possible. So again, if we have a rectangular, let's see if I can work this out. That's actually not going to work out. That's not the way that I wanted to draw it. So that was supposed to be a rectangular prism. Actually, what I'll do is this way. I'll throw it to the back, that goes back there. Look at this. I wrote it the wrong way. So there we go. There is, let's say that is my pool. It's a rectangular pool, right? There's a much nicer picture over here on the right. We get the idea. There's a rectangular pool. Obviously, it is filled up with water, right? It's obviously filled up with water. So let's go ahead and just label a couple of these things. It says that the length is 10 meters. So I'm going to go ahead and put 10 meters. Okay. The width is 5 meters. So this side over here is 5 meters. And then the depth, right? So the depth is the height of the pool, right? How deep is it? You can think of that as your height. That's also going to be 5 meters. But it says you want to increase the width to 10 meters and the depth to 10 meters. How much more water will the pool now hold? Okay, so let's first figure out what was it before, how much would it hold before, how much does it hold now that we've expanded it, and then of course we're going to go ahead and subtract those to figure out how much more water will the pool now hold. So let me draw the second pool, right? Obviously, let's see if I can draw it just slightly bigger here. Okay. Right, imagine, right, you made all the modifications, you made it bigger here. So let me go ahead and label a couple of things. We know that the width is 10 meters now. Okay, and the depth also 10 meters. And of course, our length is actually going to stay the same. The length is not changing. All we were changing was the width and the depth, right? Maybe we want to make sure we can dive without hitting our head at the bottom of this pool. Well, let's go ahead and find the volume for each one. Once we find the volume, how much water they can hold, we can figure out how much more water the new pool, how much more water we need to pour into the pool to fill it in. So let's start over here with the one on the left. Let's see if I can actually break apart my screen here. So to find the volume of a rectangular prism, it is just your length times your width times your height. So for this one, it would be my length is 10 times my width is 5 times my height or my depth is also 5. So I have a total volume of 5 times 5 is 25 times 10. That is 250. And this is, again, cubic meters. Okay, so this can hold 250 cubic meters of water, right, originally, but I made some modifications. I made the pool bigger, right? I expanded the width, I made it wider, and I made it deeper by 10 meters and 10 meters over here. So let's find the volume of the new one, right? After those modifications, length times width times height. So my length is 10 meters now, my width is 10 meters, and then my height is also 10 meters. So when we multiply all of that together, 10 times 10 is 100, times 10 would give us 1,000. So now I have 1,000 cubic meters, a pool that can hold 1,000 cubic meters of water, let's say. So how much more water will the pool now hold, right? If we're asking how much more, we're not just asking how much does it hold now. It holds 1,000, but how much more from previously? Well, it's the new one minus the old one. So we're going to take 1,000 and we're just simply going to subtract how much it was before, 250. So 1,000 minus 250, that gives us 750 more cubic inches of water. That is a significant amount right there, right? That is a significant amount. All right, so please be careful when you guys are answering the questions. It's not just finding volume all the time. It's not just volume. Sometimes we will have to compare, right? The old versus the new. How much more water do we have to fill in, pour in? In this case, 750 cubic meters.